Welcome back, chemistry fans. Today, what we are going to do is a limiting reactant stoichiometry problem. Okay, so let's jump right into it. Let me change my computer screen here so we can see the surface. Okay, so here we are on the surface, and what we are going to do is we are going to get measurements of these different chemicals. Okay, so we're going to put on our weighing boat here. And then I have got a scupula that is going to be used in a couple of different fashions today. And we are going to take two different chemicals. We've got sodium phosphate and we have zinc acetate. And we're going to combine these together to make a new product. We're going to make zinc phosphate and sodium acetate. Typically speaking, the phosphates are going to be our insoluble. They are going to be the one that's the solid. The sodium acetate is going to be the one that dissolves, that passes through our filter. Okay, so we want to take some amount. You and your partner are going to agree on less than a gram for each one of them. So I'm going to tare my weight so it's nothing there. And then I'm just going to put in here a rough small amount. So I've got 0.14. I need to write that down so I'm aware of how much that. Okay, so I'm going to take that now and I'm just going to place it into a beaker, and we will keep it next to the sodium so that I know what that canister or what that container is full of. And now I'm going to use the same one. I'm just going to clean it out a little bit there, and I'm going to put it on here. It's not weighing it. I'm going to use a similar amount, just a small amount of this zinc acetate. Not a whole lot, and probably even put them in equal portions. This is what you and your partner will decide on how much they're going to do. I would say small amounts are better than large amounts, because the more you have, the longer it's going to take to filter. And you don't want that to happen, because you want to try and get this accomplished. All right, so I've got exact same amounts, 0.14. So I got 0.14 grams of the one, and I have 0.14 grams of the other. Okay, so now I'm going to place this into a different beaker. So it's a little less confusing as to which each is. I don't need my scale anymore, so I can put that away. And now what I'm going to do with these, I'm just going to put some water into them. And again, the amount doesn't matter. The more water you put in, the longer it's going to take to filter through, because you have to get all of the water through. So I would say a safe amount is somewhere in that 10 milliliter range. So I'm just going to go put in a little bit of water. I even actually eyeballed that, and it went way past it. So just a sprinkle is all you're going to need probably to get these to dissolve. And I've got a stirring rod. So I'm going to go ahead and work on these, getting these stirred up and try and get these all nice and dissolved. And what you will notice is now that the little particles, they're pretty well dissolved out of here. So we've done a pretty good job with this. Now, what I will recommend is that after you've stirred one, that you will go ahead, rinse off in the sink so that you don't cross-contaminate, so you don't cause the reaction to occur too soon. So one dissolves, the other one dissolves, and then once you're ready, the two can be added together. Oh boy, it's going to take a little bit of time to dissolve this one. It's still see it in the bottom. It's a little bit better. Looks like it's fully dissolved there now. So now what I'm going to do, rinse that stirring rod, and I'm going to mix these two together. So I'm going to pour one into the other, and we should see a little bit of a change here. And we did. Notice that it got a little bit cloudy. So that's representative of a precipitant that's in this one. It is, one of them has become soluble and the other one has become insoluble. We want to trap that contaminant, if you will, into a filter. So now I'm going to pull back and I'm going to show you a little bit more of how we're going to construct this filter scenario. Okay, so hold on just a second. Ring stand is just a piece of metal. It's got a long piece of metal that stands up from it. Let me pull back my camera so you can see that in its full glory. So this is your ring stand, and we will be attaching to it an iron ring. So this iron ring is going to attach to the ring stand, and that is going to allow us then to put a filter in here. So how we do that is we put a funnel, and the funnel will rest inside of that iron ring. And then we're going to take a piece of filter paper, and I'm going to switch my camera so we can see this a little bit better. Now we are going to take this piece of filter and we're going to fold it in half, crease it down the middle, and then we're going to fold it into fourths. And what you're going to do is you're going to open up just one portion of that funnel, or that filter paper, and what it will allow you to do is see that it's now conical in shape. And that's what goes into the filter. So now this thing is a little bit high, so let me try and lower it down here so you can see inside of it. And remember how we have two containers, so we're going to put the other container underneath so that we can capture whatever does not filter out of this. And what we're going to do is we're going to slowly pour all of our contents into this filter here, and it's going to wet it, and it's going to try and stop all of the precipitants from going through. Now, if you want, most of that, it looks like fit in there. If you want to rinse your cup just a little bit to make sure there's nothing else in here, swirl it around a little bit, and then pour those last little bits in there, that would be wise and advisable to you. Okay, now, it's a slow process, so this takes a little bit of a time. So what I'm going to do right now instead is I'm going to start working. So I'm going to slide this off to the side, and I'm going to now start working on the stoichiometry. So let's figure out what is the balance reaction for this thing. So we've got Na3PO4 plus Vn, and it's going to be this acetate, C2H3O2, 2. And this is going to be a double replacement reaction. So what are the products going to be for this one? Well, they are going to switch places. The metals are going to switch places. So I'm going to end up with NaC2H3O2. They are going to be in a 1-to-1 because this is a positive 1. This is a -1 charge on the acetate. And then the zinc has a charge of +2. I know that because of the charge of the acetate, or the number of acetates here. So I'm going to have zinc plus PO4, which has a charge of -3, but the zinc has a charge of 2. So this is not balanced now. So I'm going to need to figure that out. And if I have 2 acetates, I would need to put a 2 right here. However, notice there's a 3 over here. So I'm going to have to make this even. So I'm going to do a 6. So once I have 6 here, that gives me 6 of the acetates, meaning I need to put a 3 here. I've got 3 here. I've already got 2 phosphates. I got 2 phosphates. This is now balanced. So what I'm going to do is I am going to put 0.14 as my starting material of both of these materials. These are in grams. And we're going to try and figure out what was the limiting reactant and see then if we can calculate what that's going to be, match that up with our work over here. But first, I'm going to get my calculator. Okay, here we are. So I'm going to add up my weight. So I've got 0.14 over 2 times the weight of all these sodiums. Each sodium weighs 23. That's 3 of those, plus 1 phosphorus, plus 4 oxygens is 64. That weighs 164. Now for the zinc acetate, same starting amount. The coefficient is 3 in front. The zinc weighs 65. There are 4 of the nitrogen, 4 of the carbons. There are 6 hydrogens, and there are 4 oxygens. That's 64. All right, so that's 183. Now, both of these are going to make, as I stated before, the product is going to be what we're going to be comparing them to. So this is what we need to figure out. This for both of them is over here, the X. So let's add up the weights. It's going to be 1 is the coefficient on both cases. And zincs weigh 65. There are 3 of those zincs. There are 2 phosphorus. And there are 8 of the oxygens. That's 385. So my values here, after we cross multiply, we're going to solve and we're going to figure out what was the limiting reactant. Do the same down here, 0.14 times 385 divided by 3 divided by 183, and we get 0.098 grams. Okay, so these are our amounts. So what it appears then, this is my theoretical yield. Right, good. But how much is the, what is the limiting reactant on this one? Well, it appears that the second one is going to be the limiting reactant. So that means the zinc acetate was the limiting reactant. But now let's figure out what was our theoretical, I'm sorry, that was my theoretical yield. And so now I've got to figure out what my actual is. And so that comes from us taking what's in the filter. So let's look at the progress on the filter now. Move the camera over here, and it's getting pretty doggone close. If we look at what we are seeing, it's very close, but I'm going to go ahead. I'm probably going to just pause the video here so that we can streamline this process. You don't have to wait quite as much. Now, normally, what we would do at this point is we would just allow this to set overnight, and it could then cause it to dry out, but we're going to speed up the process. So what we're going to do is we're going to take our filter out of the funnel. Got a little bit of water still in it, and it's a little bit gelatinous, jelly-like. We're going to then take this sucker, and we are going to put it on the heater. So what you're going to see next is me taking the camera over here. And what we're going to do with this now is I have the funnel, you can see it, the filter rather, inside of an evaporating dish on a heating plate, and we are going to hasten the evaporation of the stuff that's inside so we can get to our final weight. Now, I needed to also get the weight of the filter so I can subtract that. So let me tell you what that is. Hold on. Well dried up. You can notice that there seems to be now a solid mass on here, and it's starting to actually even flake because it's so dry. So this is not any longer jelly. So it has majority, if not all, of the water has been removed from it. So now we can get a weight on this value here, and then we can subtract and figure out how much our percent is. Hold on. Okay, so I'm going to move the camera back over here. I'm now going to turn off my heat, and I'm going to now get my zero on my weight, as you can see, and I'm going to go ahead and weigh this. I'm going to fold it up, and I'm just going to put a weight on here. And you can't see that, so let me see if I can fold this back up here. Now you probably at least can better see it. Not putting it all on here, so you're just gonna have to trust me on this one. 3.9. Okay. So with that weight, back to the math board here, 3.9 minus 3.12, we're talking 0.78 grams is what we captured. All right, the big error in there, right? So let's utilize this now, and that is what hopefully is going to become part of our story here. So our percent yield is going to be actual divided by theoretical. Well, that means I've got a huge percent error, right? 0.78 divided by 0.098 means I've got roughly a 796% error or yield, which roughly means I've got about I've got about 700% error. Yeah, about 700% error. All right, that's as good as it got today. Thank you very much. Hopefully yours will do better. We'll talk to you again soon. Bye-bye. Oh, hold on. Cancel. Let me say it this way. Now let's say goodbye. Thank you so much for studying with me. Bye-bye.